Yeah, welcome to. We're a little bit late into this session, but let's get straight into it. This is HTTP2 and what it means for the Java EE ecosystem. And joining us, as you just heard, actually Reza Rahman. So welcome, Reza. Is this your first time with the vJUG, actually, Reza, or have you been here?
Indeed.
It is. Oh, welcome. Yeah. An extra special welcome there. And our sponsor for this session is Tommy Tribe. As our silver sponsor, and we also have the JUG MTY participating as well, who we'll talk to in just a second. So a quick slide about our sponsor for this session, Tommy Tribe, in partnership with Sonatype. Another Equifax is coming. We can help. Sorry, I was about to say, can we help? We can help. So yeah, Apache, Tomcat, and Tommy, a really interesting piece of technology. Been around for quite a while now, Tommy, actually. And it's a very mature app server which provides EE support with the Tomcat look and feel. So those of you who are using Tomcat and want some more enterprise features, do very strongly consider Tommy. And of course, Tommy Tribe provide 24/7 open source security support as well for that. So TommyTribe.com, TribeStream.io, and MicroProfile.io as well. Tommy Tribe are one of the main partners, or one of the very active partners in the MicroProfile movement as well. So do check them out. And the virtual JUG is sponsored by Zero Turnaround as well, provider of some revolutionary developer tools. So if you're interested about your developer productivity, or interested about how you can run your performance tests and catch performance regressions as early as development and test, do go to the zeroturnaround.com website as well to check that out. For this session, though, you can join us on Slack. We haven't had anyone join Slack for an hour or two. I'm wondering if the link is maybe disabled, so I'll refresh that link. But yeah, if you go to the vJUG24.com site or the virtualjug.com site, there'll be a Slack image there which you can click, and that'll take you directly into the virtual JUG Slack, where you can ask questions in the live session chat channel. I'll ask those questions directly to Reza. You can also talk on Twitter using the hashtag. I almost said pound then. The hashtag vJUG24. And join the conversation there. And if you're just joining us, please make sure you do increase the video quality of your video just by clicking the settings cog at the bottom, and increase that as high as you can go. So so that's all the let me find that. There we go. So that's the bookkeeping out the way. There we go. And so who do we have? We have Alex on board as well from the JUG MTY. Alex, whereabouts are you from? Mexico? Is that right? Mexican JUG?
Yeah, we're in Monterrey, Mexico.
In Monterrey, Mexico. Awesome. Well, welcome to the virtual JUG, and we'll be asking questions a little bit later. So do grab all your questions and ask them to Reza a little bit later in the session. So Reza, whereabouts are you right now? Are you at home, or are you on the road?
Oh, I'm definitely at home.
You're definitely at home.
Probably can see. I'm in Philly.
Philly. Oh, nice. And so the time in Philly is probably about what, maybe 8
p.m. Yep.
Okay, so we're just 1 in the morning here, so we're on the night shift here in the UK. But okay, so in your own time, let's get going with the session.
Absolutely. Okay, so let me, I think, share my screen.
Mm-hmm.
That would be a good way to get started. Okay, so the first thing I want to point out, actually, before I actually really start speaking and sort of going into the lecture portion of the talk, the slides for this is available. It is on Speaker Deck under my account. That's the full URL there, if you'd like to check it out. So everything that I speak here really is available and public already in some shape or form. So what am I talking about? I'm talking about HTTP 2.0 and what it means for the Java EE ecosystem. In particular, really, I'm going to spend a little bit of time covering Servlet 4, which is the latest version of the Servlet specification that was just released and is part of the larger Java E8 umbrella. Won't be covering Java E8 too much, though I do recommend that you check out the Java E8 release as well, in addition to Servlet 4. But Servlet 4 is certainly one of the largest, most significant features that were added in Java E8. Okay, so a bit about my company. Obviously, they're kind enough to let me do this stuff. My company's name is CapTech. We're a US national IT consulting firm, essentially full-service IT consulting firm, not just Java, but certainly a large part of it is Java. Win a bunch of awards, obviously, and try to hire the best people and try to do good by them. Okay, so first let's talk about HTTP 2.0 and talk about why HTTP 2.0 and what is this actually really about. It's actually a foundationally important thing that you should absolutely know about. If you don't know about HTTP 2.0, you really would be doing yourself a disfavor as a not just a server-side Java developer, but any kind of server-side Java developer for that matter. In order to understand what HTTP 2.0 is about, you'll sort of have to take a time machine trip back into the early part of the internet revolution. So for those of you who are not familiar with what you're looking at on screen right now, this is basically the NSCA, the first ever web browser created in the world. Its name is NSCA Mosaic. Okay, for those of you who are not familiar with NSCA Mosaic. So a lot of what HTTP 2.0 is about adjusting to the realities of how the world has changed from the world of Mosaic to the world we are living in right now. So if you look at this particular page that is on the screen right now, this is how the world looked like during the world of Mosaic. So largely an HTML page, when you opened up a URL and you opened up a HTML page, it really did look like just the HTML page. So it's really a bunch of text, as you can see on screen, with perhaps some one or two images where it's absolutely helpful, but and certainly hyperlinks. And the hyperlinks are the basic mechanism where you go from one page to the other, and that's it. Really, not much more than that. In terms of modern websites, I think you can think of Wikipedia as a rough equivalent of what you would see of the web as it was during the era of NSA Mosaic. So in this world, what HTTP 1.1 and 1.2 made a lot of sense in the sense that really it's a request response-based protocol. The basic assumption here is that when you are requesting a web resource, really it is a singular resource that you will be requesting, and it's a self-sufficient resource that by and large is able to render meaningfully on the page on its own. So it's a unit one-on-one interaction. The problem, though, is the web of today looks very different than it did in the era of NSA Mosaic when something like HTTP 1.1 was designed. Today, if you look at most websites, they will look like much of what I have on screen at the moment. I happen to be using ABC News as website, but if you go to pretty much any major corporate website, whether it's CNN or Amazon or eBay or BBC or what have you, you'll see a similar type of format. And what's different about this format is that when you are now making an initial HTTP request and you're getting the page back, you're not just getting a single HTML page back. What you're getting is a lot of content embedded within that page that is expected to be rendered with that page. So there is going to be a lot of images, perhaps embedded video, embedded sound, certainly a lot of CSS, certainly a lot of JavaScript. And in fact, Google did a little bit of a study, and on average, a single page, a single GET request, HTTP 1.1 GET request, actually results in on average, about 40 other HTTP requests before a page can render. So obviously, this is extremely wasteful. So in order to just render a single page, you're not just making one HTTP request, but near about 30 or 40 or 50 different HTTP requests before you're even able to render a single resource. And each of these interactions are creating separate connections with separate open and close phases, as well as protocol handshakes every single time. So incredibly wasteful. Other than being wasteful in terms of connection usage, there's a few other problems with HTTP 1.1 as well. One well-known issue is called head-of-line blocking. So not only are you restricted in terms of what you can do with a single connection, you're also restricted in what order the server will actually serve up those connection requests. So let's say in this example, I have an request to index.html, and the browser parses that index.html and figures out, okay, I have a request for style 1, style 2, script 1, and script 2, and it makes those requests to the server in that sequence, in the sequence that it encounters them in the index.html page. Well, guess what? The server is now required to serve up those requests in the order that it received them. So, which is well and fine, but it's problematic when you have one resource that is sort of a bottleneck. So this is a good example in this graphic that I have here. So let's assume that, okay, we're supposed to serve up these requests in the sequence we receive them. So we serve up style 1 and style 2. Well, guess what? Script 1 is a very heavyweight resource, and that it will take significantly longer to load than any of the other resources. Well, guess what? Because of that fact, you will not be able to load script 2 until script 1 is done. So the sequencing, the strict sequencing in the HTTP 1.1 world causes this essentially blockage or forced sequencing of these requests, adding to the latency problem in addition to creating a bunch of connections. Now, if matters couldn't be worse, you're also restricted in general as to how many resources, how many connections you can make simultaneously from a given client to a given server. Usually it's restricted to about 4. So this poses another problem, and there's a solution to this called domain sharding, which I'll talk about in just a second. But basically, domain sharding is about fooling to get around this restriction of about 4 connections from a single browser to a single server. Well, the way you defeat that, if you have to load 40 different resources to load a particular page, is that you distributed out your resources across multiple servers. So you make the client think that, okay, it's actually talking to different servers, and hence it's okay for it to make more than 4 connections at the same time. So people have come up over the years with multiple ways of dealing with these problems, and these are some of the ways that people get across these problems. So one is called Falcon, Catenation, and image sprites. So the idea here is that, okay, so if we're to load up, with my index.html page, a lot of JavaScript and CSS and all of these things, well, what I can do is I can concatenate all of these files together, okay, and serve them up all at the same time. Instead of serving them up one by one in each different HTTP call. And similarly for images. So if you're using 10 different images, well, instead of loading up 10 different HTTP requests, what you can do is you can create one big image and use image sprites in JavaScript or in CSS to show parts of an image and make it look like, okay, it's really multiple images. Domain sharding I already talked about. Basically, this is to defeat that number of concurrent connections to a server problem. And the way you do that is you distribute out your resources across multiple servers. And inlined assets is very, very similar to image sprites. So basically, this is instead of concatenating, you actually embed whatever it is that you need within your work page. A good example is essentially if you have video, then you ASCII encode that video within your page, and then ASCII decode it on that page using some JavaScript. Okay, so a bunch of very sophisticated and complex techniques to try and get around the limitations of HTTP 1.1. So HTTP 2.0 is really about recognizing these problems and saying that, okay, all of the basic assumptions that we made in the HTTP 1.1 era no longer hold. in this new world. So we really need to come up with a protocol that can handle that, changes those fundamental assumptions and optimizes to match what the reality is now. Well, the problem with doing that is that you cannot simply rip and replace a fundamental protocol like HTTP. The entire world basically runs on HTTP. So you can't, whatever change you have to make, you have to retain some notion of backwards compatibility. So the good news is that's exactly what happened. Is basically the changes that happened in HTTP 2.0 is really at the transport layer. It's not at the layer where applications reside. So the API, the basic API for applications looks very much the same. It's really the underlying plumbing. So the lower level TCP/IP based protocol that the browser and the server are using to communicate, that's what's changing. That's what's different about HTTP 2.0. Semantically, it looks exactly very much the same. So it's the same request response based model. There's no new methods, no new headers, no new URLs or ports, and that retains basically the backward compatible. So it's a very clever solution to a very complex problem, actually. Another big change, though, besides changing and a sort of philosophical shift between HTTP 1.1 and HTTP 2.0, is that sockets are essentially treated as a scarce resource. So you are actually limited now, not to 4, but only just one connection between a client and a server. Okay, so before you had this, right? So you had a bunch of different servers and a bunch of different resource interaction, a bunch of different connections, parallel connections. Well, guess not. Now you have this. Okay, so you have to have just one client and one server, and a single connection by which you are supposed to essentially serve up multiple resources. Okay, and this should be a puzzle. So how do you do that, right? So it should worry you. So now you have to use a single connection to do all of this other stuff, whereas you are using multiple connections before to serve up all of these concurrent resources. So the trick here is actually quite old. The basic trick is something that's been used in TCP/IP for a very long time. It's called multiplexing. So multiplexing is a technique by which you get to share basically your resource. So instead of a connection being a single house with a single family, a connection now becomes a flat, and that's subdivided into blocks. And within each of those blocks, you can have, if you will, separate families living in it. Besides that, there's a bunch of other changes that have also taken place in HTTP 2.0. So it's not just about just multiplexing, although multiplexing is the biggest change. All of these changes I'll talk to you about, but I'll mention it briefly here. So binary framing is a big one. So HTTP 1.1 right now is a ASCII-based protocol. All of this is going to be now turning into binary, which will provide additional optimization right out of the gate. There's also other techniques like stream prioritization, server push, header compression, as well as HTTP 2 upgrade, both using ALPN as well as 101 switching protocols. Okay, so obviously not a lot of this is going to make sense to you right away. Obviously, the rest of the 15-20 minutes here is about explaining these things. So don't worry too much right now if this is not very clear to you right away. So first, let's talk a bit more detail about precisely what request response multiplexing actually means. Right? So, and I sort of talked about this before. So before, a connection really was meant it's just single request and a single resource, single response. Now that's not what a connection means. So a connection is now, if you will, again shared across multiple different requests and responses. So a connection can be broken down into streams, and streams are basically the equivalent of what connections were in the HTTP 1.1 world. So it's a representation of a single response and a request. Okay, within those streams can be broken up into messages, and each of those messages are something like HTTP GET and a HTTP GET response. And even those messages now, can be broken up even further into frames. So these are basically datagrams, small parts that constitute a message. Okay, and all of this can happen in a single connection in parallel. Not sequentially, but in parallel. That's an important point to understand. So you're basically able to make parallel, not just one connection, but one connection. Across one connection, you can now share multiple resources and exchange multiple resources essentially simultaneously. Okay. So ultimately, what this means is that there's a single pipe between the browser and the server, and between the browser and the server, you can now have bidirectional, intermixed, simultaneous bits of data going back and forth. Okay, and that's allowing you essentially far more efficient usage of both the client and the server, because now you're not needing to make multiple connection requests over and over again. You can just use the same connection and not have to incur the overhead of tearing down and creating essentially the connection over and over again. Okay. Aside from this, there's another interesting optimization that was included in HTTP 1.1 and it's in HTTP 2.0. And in order to understand this, you have to stop a little bit and think about what happens when you're loading up a single page and you're making all of these multiple requests just to serve up that page. Well, what turns out is, because it's by and large effectively part of a larger unit of transaction, a lot of the headers, on each interchange actually are duplicative. Okay, so let's take a look at request 1 and request 2 in this case. So we're requesting two different images, okay, namely resource 1 and new underscore resource. But take a look at the rest of the headers here. The method, the scheme, the host, the accept, the user agent, and many other headers will basically be the same. So the only thing that is actually changing is simply the path. Okay, what is the specific resource that you are requesting? So it doesn't make sense anymore to essentially repeat all of these headers over and over again, because now you're no longer in a stateless world. You're in a stateful world. So because you are in a stateful world, both the client and the server can now keep track of what the delta is. What is my total interaction? So you can essentially imagine yourself, both the client and the server, having a hash table with all of these headers being stored. And hence, the server can tell, okay, what is the actual delta that I need to send to the client? And the client can figure out, okay, this is what has actually, the server is sending me what has actually changed. What did I not get before? And hence, I should be able to calculate what the total headers are for this particular stream, okay, or this particular resource. Stream prioritization is another important technique, optimization technique, and this also bears a little bit of thinking. So let's take for a second that we have a web page A, but that web page A depends on resources B and C. Okay, but resources B and C are not created equal. So actually, when it comes down to it, C is more important to load up before B. So you can essentially express that preference both between the client and the server by assigning weights to each stream. So you can say B has a priority of 4 and C has a priority of 12. So if you have to choose, please pick C first. Similarly, if there were 3 resources, B, D, and C, well, guess what? D has the highest priority, and then second priority is C, and third priority is B. And you can nest this, right? So this can be interrelated as well. So let's say A is dependent on D, but D is dependent on B and C. Well, all of these resources you can assign priorities to, and basically what will happen under the hood is that the browser and the server will make sure those resources are loaded first and are given more attention. Lastly, one of the more interesting features added in HTTP 2.0 is something called server push. And in order to understand that, you have to go back to that fundamental problem again. So you have a single index.html that you requested, but the single HTTP index.html actually depends on 10 other resources in order to be able to meaningfully render that page. Well, guess what? The browser has no way of knowing that, but the server has a way of knowing that. So when the server gets a request for index.html, it knows, okay, by the way, in this index.html, I need to really give the client 10 other resources before he can meaningfully do something. So using HTTP server push, what the server can do is say, hey, you requested index.html, but I'm going to not just give you index.html back. I'm going to give you all of these other resources back right away. You don't have to ask for it. I'm just going to give it to you. And what happens is these additional resources that are required to render index.html are actually put in the browser's cache. So when the browser finally gets around to realizing, okay, I need this additional resource, and it goes to make an invocation to the server, it says, oh, I don't need to make an invocation anymore because the server has already given me this resource, and it's sitting right here in my cache. Right? So it helps in terms of perceived efficiency of how fast the page is loading. Okay. Lastly, there's another important technique introduced in HTTP 2.0, and this is necessary, again, for backwards compatibility reasons. So basically, when you have an intermixing of HTTP 1.1 and HTTP 2.0, not every single browser in the world is certainly going to be talking HTTP 2.0. Some percentage of them are going to continue to talk HTTP 1.1. So how do you figure out what do you serve? So the way you do that is using this HTTP upgrade technique. So basically what happens here is that the default assumption is that you're always going to use HTTP 1.1. However, the client itself, if it supports HTTP 2.0, will request HTTP 2.0 and say, hey, I want HTTP 2.0. And if the server also supports HTTP 2.0, then it will say, yes, I also can speak HTTP 2.0. So now let's switch our protocol from HTTP 1.1 to HTTP 2.0. Okay, and there's a similar kind of technique for secure in security interactions as well. There's a specific negotiation protocol that's created for this problem. It's called application layer protocol negotiation. Okay, and it basically does exactly the same thing. Okay, just make sure that HTTP 1.1 and HTTP 2.0 can coexist with each other seamlessly. So all of that is a bunch of theory, right? Let's take a look at this in practice. If you're not convinced yet that that this HTTP 2.0 stuff is really worth your time. So I have a little demo. It's a nice little handy website that exists out there that helps you understand what the value proposition of HTTP 2.0 actually is. So bear with me a second. I'm going to go ahead and load this page, okay? And I'll tell you what exactly goes on when I do that. Okay, so notice this little image, right, on my left hand, the way I'm sitting on my left-hand side. It took a little while to load, right, because it's actually this image is actually a composite of many different images, and you could visibly see, okay, it's loading each little image, right, and it's using HTTP 1.1 under the hood, and it took 3.19 seconds to load. Okay. Now, when I hit this button, it's going to do exactly the same thing, but using HTTP 2.0, and notice the difference. Okay, it's virtually instantaneous. You couldn't even tell that it's actually many different images being composited. I'll do it again, unless just in case you're still not convinced. So hopefully that convinces you that this is something worth doing. In fact, there's a studies. You can only trust those studies so much because these are benchmarks with people with agendas. But regardless, so the benchmarks out there that you see there is basically saying that if from HTTP 1.1 to HTTP 2.0, you can see basically a magnitude of improvement of about 10 times, right? So your website appears 10 times faster to your user. So imagine that just by upgrading this web server from HTTP 1.1 to HTTP 2.0, you're suddenly increasing your user experience tenfold, right? So this is nothing to sneeze at. This is very big stuff. You need to be taking advantage of this if you have any kind of website or any kind of server-side app whatsoever. So the nice thing is you can, and I'm not joking you can forget about everything that I just told you. Okay, the reason for this is that in the Java world we have a nice little abstraction called Servlet that makes all this stuff go away for us. It makes it all this stuff implementation details. Okay, how is that? So let's take a look. So as it so happens, the Servlet API is actually extremely well positioned for HTTP 2.0 because unlike many other protocols, Servlet is actually designed to be very high level. So it actually sits above the low level protocols of HTTP. When you looking at Servlet, you're not really looking at what's going on under the hood with the HTTP protocol. That means that most of these changes, because most of these changes that I just said are done in a way that it doesn't change the API contract, it just changes the underlying protocol implementation. That means that an API like Servlet can remain almost exactly the way it is. Okay, so basically what this means to you, translation, is that when you upgrade your Servlet engine from HTTP from Servlet 3.1 to Servlet 4.0, you will automatically get those performance benefits that are promised in HTTP 2.0 without, without actually needing to change your application at all. Okay, well, that's not entirely true. We'll see that in a second. So how does this happen? It's an interesting question to ask. Besides being a higher level protocol, the other fundamental challenge here is, think about this now. So before you had a one-to-one mapping between a request and a response. So you had a do-get method, right? So if you get a request, you get a service or a do-get or a do-post invocation, and that's one interaction. Now you can have multiple interactions per a given connection. So how do you handle this? And the simple answer is that, again, it's that servlet abstraction, right? So although the servlet engine under the hood is probably needing to invoke the service method, the do-get method, and do-post method multiple times at the engine level, that is transparent to you, right? You're not aware of that because the servlet engine is doing that under the hood on your behalf. From your perspective, it looks like, okay, nothing has changed. Okay, I'm just getting the same old service request I always have. And in fact, the Servlet API can hide most of these things. Let's transpose these in terms of the major features of HTTP 2.0. So request multiplexing, binary framing, stream prioritization, header compression. These are all things that essentially are handled for you at a layer below the Servlet API. Okay. But there are a couple of things, though, that does require API changes in the servlet layer. So the big one is actually server push. The other one is HTTP 2 upgrade, namely one-on-one switching protocols. The good news is I won't talk too much about the HTTP 2 upgrade one-on-one switching protocols because this was a change that was made in Servlet 3.1. Okay, so in Servlet 3.1, the Servlet API added this support principally to support WebSocket. WebSocket uses this exact same technique as HTTP 2.0 upgrades. It also uses the one-on-one switching protocols. So no changes for this particular change. It does mean that this particular HTTP 2.0 feature is surfaced in the Servlet API, but it so happens that we already made that change. Okay, in Servlet 3.1. So really, the big change in terms of API is just server push. Okay, so in terms of Servlet 4 new features, really these are the two big ticket features in terms of HTTP 2 support. Number one, HTTP 2 is required. Okay, That's a small sentence, but it means a very big things. What this means is that in order for a servlet engine to pass Servlet 4, it must pass a number of tests that are in there in the Servlet 4 TCK, or compatibility test kit, that ensures that HTTP2 is properly implemented by the servlet engine. Okay, this is very unique. HTTP2, there's no HTTP 2.0 TCK, by the way, right? So everybody outside of the Java world that are claiming they are HTTP2 compatible, there's no way they can prove that. Okay, in the Java world, in servlet providers can prove that by running the Servlet 4 TCK. So this is a very big deal. Okay, as to why Servlet 4 is so important for us. It means that as an industry, as the Java ecosystem, we can now uniformly say, yes, we know we support HTTP 2.0 because these Servlet 4 compatible servlets are passing the Servlet 4 TCK. Okay. Server push is another important one that requires an API change, and I'll talk to you. I'll spend a little bit more time here talking about that. Okay. So as I said, HTTP 2.0 does surface as an API change, and this is the API change. Okay, so this is the big API change. It's a new method that is added in the HTTP servlet request. Okay, it's called get push builder, and it gives you a handle to a push builder. And the push builder is nothing much more than an abstraction that allows you to create a set of simulate essentially a set of requests. Okay, so basically you can add headers, you can add e tags, get loss modified, get query string, get session IDs and paths and the like. Okay, so everything that's required for you to construct a meaningful additional HTTP resource invocation. Okay, and the magic method here is push. So each time you're invoking push, it's actually simulating you sending out yet another resource, a new resource down to the browser. So if you put this in a sequence diagram, it's a little bit easier to understand. So let's assume here that there's a servlet service method intended to serve up index.html, the index.html page. So in this service method, you're going to say, hey, I know that this index.html actually needs style.css and script.js. So you will construct a get push builder by invoking request.getPushBuilder, and then you are going to do, say, set path style.css and push, and set path script.js and push. Okay, and under the hood, what that will do is that now, in addition to giving the browser the index.html, the servlet engine will also give the browser this style.css and script.js in that same connection, okay, without the browser requesting these resources. Now, the reality is most of us are probably not writing servlets these days. Okay, so if you are, kudos to you. You can make use of servlet push. But in reality, the servlet push feature is actually intended for framework writers. Okay, so all of the frameworks that higher level frameworks that we are using now that depend upon servlet, those frameworks can use this server push feature under the hood to take advantage of this new optimization added in HTTP 2.0. Okay, so in fact, this is an example here. This is an example using JSF. So JSF, the main JSF implementation depends on something called Faces Servlet. The nice thing about JSF is JSF knows about resources. Okay, we added this feature in JSF, I believe in JSF 2.1. Okay, and so in Java E7. So basically, JSF knows that for a given JSF page, there's a number of resources that are registered for that. Okay, so when it serves up that JSF page, it can also transitively serve up and do a server push on those dependent registered resources. Okay, so if you look in specifically the resource handling portion of JSF, it has that exact API. It's saying servlet request .getPushBuilder.path.push, and it's doing that for every single registered resource that is associated with a single JSF page. And frankly, you can do that pretty much in every major. You can do a very similar technique in every major server-side web framework out there. It's not just JSF, right? So you can certainly modify something like, let's say, Spring MVC to take advantage of these same things. So have some sense of, okay, what are dependent resources for a given page, and let me automatically do a server push without the developer doing much else other than simply telling me that these are the dependent resources that need to be loaded. So all of this is real. Okay, so these are not just specs. Finally, it's part of Java E8. It was just released actually just a few weeks ago. So all of this is now reality. And if you've been paying any attention to the news, this has been a really hard journey for some of us. It's a hard-earned release and hard-earned Servlet 4. So honestly, it's a small personal victory for me and many others to be able to do this talk today. So you can go and download Glassfish 5.0 now, and Glassfish 5.0 is Servlet 4 compatible. You can test all of this stuff out yourself and see how it looks like. How does it look like to do Servlet push, and what is the performance difference between the prior version of Glassfish, which is Glassfish 4.1, and Glassfish 5.0 in terms of page loading. Okay, and hopefully there will be shortly more Servlet engines that are that implement the Servlet 4 API. I hope so. It's already a long time coming, the HTTP, so the Servlet 4 implementation. So hopefully we will see a bunch of implementations coming sooner rather than later, and not just Glassfish 5 necessarily. Okay, so again, HTTP 2, a long time in the making, almost 15 years. Definitely a very promising thing that we should all be taking advantage of. Even better news is we can take advantage of it now thanks to Servlet 4. And it's all real. You can hopefully try it out and take advantage of HTTP 2.0 in your web apps, certainly if you're using JSF, and even if you're not using JSF, you can talk to your framework provider and make sure they take advantage of, take advantage of HTTP 2 under the hood. Okay, a few small resources that I will share with you. All of what I explained in terms of HTTP 2.0, I actually didn't do it by myself, thankfully. It's a huge spec. I would probably go insane if I tried to figure it out by myself. There's a really nice website out there. It's called, it's specific just to HTTP 2.0. You can read through that website. Everything that I explained here today, you can explore in much greater detail and hopefully even better explained in that website. And of course, a link to the Servlet spec itself, if you wanted to take a look at the nitty-gritty of the Servlet spec. The Servlet spec.java.net, we're soon moving to GitHub and soon moving to the Eclipse Foundation, and I hope you're paying attention to what all that is going on there as well. Okay, so that is it in terms of lecture from me. Let me just see how I am doing in terms of time. I think I can stop sharing my my screen now. Actually, before I stop sharing my screen, again, let me show you the URL there. So it's a speaker deck website. Okay, it's under my account, and that is the URL for it. I hope it's relatively easy to Google and find out as well. But it's on speaker deck.
Okay. I'll be sending out a request for all slides as well, so from speakers. So I'll grab that off you at some point in the future, and we'll put that together with the replay. So we'll have that all in one place as well.
Okay, fantastic. So I'm going to go ahead and stop sharing. And here I am. You get to look at my ugly mug some more. So what's up? Any questions, concerns?
So I've got a couple of questions. One from Carlos. We'll pop by Alex as well in a second. Carlos says, is there any integration coming for JAX RS and HTTP2?
It's an interesting question. So JAX RS can certainly take advantage of some HTTP2 optimizations, and it will. So binary framing is an obvious one. But because REST, it doesn't really fit that problem set. REST generally it does follow that one-to-one request response paradigm. So if you're a REST user, you probably won't get that much of a benefit out of HTTP 2.0, right? So, but certainly you'll get benefits out of it if you're a more traditional website. You have a website that's using even something like Angular, right? So even those Angular resources will load much faster with HTTP 2.0 than it will with HTTP 1.1. But not so much for REST development. It really you won't see those many of those performance benefits really.
And if we talk a little bit, if we go to Java SE rather than EE, in version 9 of the JDK, HTTP2 support is an incubator project rather than a like in the JDK spec. Is that a big deal, or is people just going to use libraries, I guess, to make use of HTTP2 and SE?
To be honest, me being a consultant, most people, why would you use an HTTP library? Generally, you would use it to make REST invocations. Most people have been using REST. In the Java E world, they use really the JAX-RS client API. The Spring guys use Spring REST template. I don't see a lot of usage at this stage of who's going to use this Java SE HTTP library. I don't know, right? Maybe there's some folks that feel very strongly about just not having any dependencies and just using whatever Java SE provides. Certainly, those folks can take advantage of the new HTTP library that's included in the JDK. But frankly, I haven't seen it yet in real life. Most people in real life are using, as I said, either JAX-RS client API or essentially Spring REST template.
Okay, Alex, do we have any questions?
So it was on the same direction as you. I was wondering, in the standard edition, which version of the GRE and JDK includes HTTP2 support?
So there's no HTTP2 support in SE8. HTTP2 came out after after SE8. In SE9, as Simon pointed out, there's a beta API, sort of not an official API that adds HTTP2 client support, meaning you can essentially invoke HTTP2 servers through this client API. In fact, not just HTTP2 servers per se, just HTTP servers. You can actually invoke plain old HTTP 1.1 servers if you want as well through this new API in Java SE.
Okay, we have another question from Slack. What about taking advantages of HTTP for things like Hateos?
Do you know what that is, Simon? Can you tell me a bit more what that question actually means?
Maybe I'm pronouncing it wrong. I think it's the hypermedia driven system. It's HateOAS maybe.
Oh, okay, got it. HateOS. Yes.
Yeah.
Okay, I got it. So the answer is no. HateOS is really about it's basically hyperlink. It's hyperlinking for REST APIs. So it's making use of hyperlinks in REST semantics. So again, there's not a lot of use cases where you're doing that type of interaction where you have a single resource and then from a single resource you are producing multiple links at the multiple resources simultaneously. So that's a rare case. It's usually a one-on-one interaction. So if you're doing HateOS, for example, you'll say, okay, this is this resource. If you want to get more information about this resource, follow this other link that I'm also sending you, that kind of thing. It's not so much about loading those dependent resources. HateOS is really more about once you load something else, you have a hook that gives you, okay, this is what I'm going to do next, right? So it's maybe a set of URLs that you follow depending upon what your API signature is. It's a long, convoluted discussion, so it's a little bit hard to explain right away. But again, not so much. No, I don't see I don't see any big correlation between HTTP2 and HateOS now.
Okay. There's no other questions in Slack right now. Just checking the channels. Okay, that's all the questions from Slack. Actually, one thing I will add. So, if anyone is in the Monterey metro area, if they tweet hashtag JUGMTY to Alex Mayorga, you can get some of the vJUG24 t-shirts delivered in that area. So, so if you do that, you can get some nice vJUG24 shirts. So yeah, no other questions in at the moment. So anything you want to finish with, Reza?
Yeah. So the only thing I'll say is, honestly, I kind of sort of wish this was the Java EE8 talk instead of the Servlet talk. So Servlet, although it's a very important part of Java SC as Java EE8, honestly, there's a lot more very important things that developers should be looking at in terms of Java EE8. That's very, very valuable for a lot of developers out there. I'll just say a few of them. There's a brand new security API. I think it's the most polished security and easy to use security API out there. There's new support for a JSON binding API right out of the platform. It's super easy to use. And a bunch of stuff to align a bunch of APIs with Java SC8, okay, in particular. So things like JSF, JPA, bean validation, all of those APIs are now essentially all Java SC8 compatible. So really a bunch of very good stuff that came out of Java. It came out in Java 8 aside from just Servlet. So people should definitely take a look at some of that. And it's in the same place. If you go to my Speaker Deck account, if you just look around a bit, you'll see a Java EE8 tech there as well.
And where can people grab implementations of them from? Just to grab it, have a play.
So obviously, that's the other nice thing about it. So the link that I shared, /5.0, that is not just a Servlet 4 implementation. It's actually implementation of the entire Java EE8 API. And the nice thing is actually the vendors have been pretty aggressive this time. They're already adding some support in Java EE8, both in Open Liberty or WebSphere Liberty or whatever you want to call it, as well as in Wildfly as well. I just saw a tweet from the Wildfly folks that in Wildfly 12, which is the next release, okay, they're going to be starting to add Java EE8 features. So that is definitely much faster than we have seen ever.
Yeah, I do remember the days when in my past when I was a developer on the full kind of profile WebSphere, where a release would come out and then 2 years, it would literally be like a year or two later before you'd get a full Java EE support for, whatever it is, version 6 EE support, full kind of stamped. Whereas these days, I think because a lot of the app servers are becoming more lightweight and modular, particularly, I mean, well, my history would be with Liberty. It's easy for them just to release one module, one piece with an updated servlet implementation or whatever it is, right? So people, I think servers and people are more and more likely to just say we're not gonna throw one major upgrade of an umbrella specification, but we're gonna as we go, we're gonna deliver small pieces of the spec. So yeah, we'll have servlets here today. We'll have JAX-B. We'll have all these little incrementations. Now at some point, yeah, that you will have full support for this umbrella kind of platform. But it's nice for people to be able to kind of get that gradually rather than in one kind of lump sum.
So the one other thing I was going to add is the Pyara guys are probably going to be next, right? They're going to be probably the second implementation after Glassfish 5, and I think they're on a pretty aggressive schedule. I would be very surprised if by January there wasn't a Pyara implementation of essentially Pyara commercialized implementation of Java EE8 as well.
Awesome, sounds good. Look forward to that, and massive thank you to Reza for first session on the Virtual Jug, hopefully one of many, and a big thank you also to Monterey Jug for joining as well. So what do we have next? Next we have Sota talking about radically reactive web apps with Vertex, Eclipse Vertex, and that's going to be with the Ecuador Jug right after this. So we'll have a 5-minute break, and we'll catch up with you then. So a massive thank you to both Reza and Alex for joining. Thank you.
Absolutely, my pleasure.
Cheers.